Welcome to this discussion on time and work. This is an important area as far as aptitude preparations are concerned for two reasons. Firstly, the concepts that we build here are applicable in a variety of situations. And two, you can expect questions from this section in most of the aptitude tests. After this discussion, you will be thorough on the concept of man days. Let us begin with some simple examples. Look at the following situation. Anuradha, a typist, gets a work of typing 200 pages of handwritten material. She wants to estimate how much time she would take to complete the work. Another example. Murugan's job is ironing clothes. He takes 4 minutes to iron a shirt. He wants to know how many shirts he can iron in a day. These are situations involving time, work, and workforce. And it is these kind of situations that form part of our discussion in this session of time and work. In some situations, the workforce involved would be a person, like Anuradha or Murugan described here, and in other cases, we would have a group of people involved. Let us revisit the first example we looked at. Here, only one person is involved, Miss Anuradha. The total work is typing 200 pages of handwritten material. It is known that Anuradha would type 10 pages of handwritten material in an hour. So in 2 hours, she would type 20 pages. In 3 hours, she would type 30 pages, and so on. In 10 hours, she would type 100 pages, and in 20 hours, she would type 20 into 10 or 200 pages. So she would take a total of 20 hours to complete the work of typing 200 pages. What if her customer wants the work to be done in 5 hours? At this rate, Anuradha will not be able to do it in 5 hours. She will have to look for more people with whom she can share the job and thereby reduce the time. In the second example of Murugan ironing shirts, let us take a typical workday of Mr. Murugan as 8 hours. Murugan irons a shirt in 4 minutes. How many shirts will he iron in an hour? 1 hour is 60 minutes. So in 1 hour, he will iron 60 by 4 or 15 shirts. So in 8 hours, he will iron 8 hours into 15 shirts per hour, which is 120 shirts. There is no rocket science involved in dealing with these kind of situations. We use common sense combined with logical thinking. Look at the question Q1 given in the slide. 10 men can construct a house in 20 days. How many days will 3 men take to construct a similar house? 10 men, 20 days. 3 men, how many days? When we give this question during classroom discussions, many students give the answer as 6 days. If you also thought that way, think again. If that was the case, why would we employ 10 men at all? 3 men would have done the work in 6 days. And if you extend that argument, 1 man would do the work in 2 days, isn't it? What's wrong here? Here you should apply your common sense. If the number of people are reduced, then definitely the number of days required would go up. Now by how much? That is something that we need to find out. To begin with, you should have it at the back of the mind that since the number of men were decreased, the number of days required would go up. So definitely, the answer is going to be more than 20 days. Let us define the amount of work done by a man in a day as a man day of work. Please keep in mind, man day is a unit of work and by definition, it is the amount of work done by a man working for a day. If a man can type 10 pages in a day, we will call the work of typing 10 pages as a man day of work. Then typing 20 pages will be 2 man days of work. If a man can iron 100 shirts in a day, the work of ironing 100 shirts can be quantified as a man day of work. Then 500 shirts will be 5 man days of work. If a man can paint 100 square feet area in a day, then the work of painting 100 square feet is a man day of work. Then painting 1000 square feet, which is 10 times 100, will be 10 man days of work. By that definition, can you quantify the work involved in construction of the house in question? It is given that 10 men require 20 days to construct the house. When one man works for a day, the amount of work done, we call it 1 man day of work. When 10 such men work for a day, they do 10 times the work done by a man in a day. So it would come to 10 man days. Now these 10 men work for 20 days. So the total work done by them in those 20 days will be 10 men into 20 days or 200 man days. So we can see that the total work involved in constructing the house is 200 man days. Now the house will be completed when this 200 man days of work is done. Let us see what happens if only one man comes for work. He will do 1 man day of work in the first day. Second day, he will do another 1 man day of work. Third day also, he will do another man day of work. And it goes on like that. For him to complete 200 man days of work, he will have to work for 200 days. If there were 2 men, then every day they would do 2 man days of work. In order to complete 200 man days, they will have to work for 100 days. Here, we have a situation where 3 men are coming to work. They will be able to do 3 man days of work in a day. Every day, they will do 3 man days of work. The number of such days required to complete the house, which is 200 man days of work, is given by 200 by 3, which is 66.6 days. Look at the question given in the slide. Here, we have 4 men who are trying to build 5 houses. All the houses are similar to the ones that we saw in the previous question. We are asked to find the number of days they will take to do that work. While looking at these kind of questions, the first thing that you should do is to quantify the total work. Let us quantify the work in terms of man days. From the discussion on the previous question, we know that construction of one such house requires 200 man days of effort. So constructing 5 similar houses would require 5 into 200, which is 1000 man days of effort. We have 4 men with us to do this work. How much work will 4 men do in a day? They will do 4 man days of effort every day. Remember, by definition, the amount of work done by a man in a day is what we call a man day. In order to complete 1000 man days of effort, they'll have to work for 1000 by 4, which is 250 days. In all these cases we discussed till now, even though it was not openly stated, we made an assumption when writing the steps and thinking through the situations. We assumed that all the men involved in the job are equally capable. For example, we defined the work done by a man in a day as a man day and then went on to say that the work done by 10 men in 20 days is 10 men into 20 days, which is 200 man days. We can write this step only if we assume that the work done by the first man in a day is the same as the work done by the second man in a day, and that is equal to the work done by the 10th man in a day. That is, we are assuming that all the men involved in the work are equally capable. This assumption is sometimes referred to as the assumption of uniformity of workforce. Here, a few things are worth noting. First one, we will assume that people within a group are of the same capability. For example, if we have a group of 5 women, we will assume that all the 5 women are equally capable. If we have a group of 25 men, we will assume that all the 25 men are of the same capability. Point number 2, we will assume that people across categories are different. For instance, if we have a heterogeneous group like 5 men and 3 women, then we will assume that all the 5 men are equally capable and that all the 3 women are equally capable. But we will not assume that men and women are of the same capability. We will assume them to be different. And similarly, separately named people are considered different. If in a question we have some people who are named separately, for example, Anil, Bimal, Sunil, etc., then even if we know that all of them are men, we should not assume that they are of the same capability unless otherwise specified in the question. Look at the question Q3 given in the slide. Here we have a certain deadline or target given. The group should finish the work in 20 days. What is the work here? It is painting 10 houses. Are all the houses identical? Yes, they are. Since all the houses are identical, we can say that the total work would be 10 times the work of painting one house. We have a group of 4 women here, and we shall assume that all the 4 women are of the same capability. Let us quantify the work done by a woman in a day as a woman day of work. It is the same as the concept of man day. If the work done by a man in a day is quantified as a man day, the work done by a woman in a day can be quantified as a woman day. It may be different from the work done by a man in a day. Now, it is given that 4 women require 5 days to paint one house. When 4 women work for a day, they will do 4 women days of work. I shall repeat. If we call the work done by a woman in a day as a woman day of work, the work done by 4 women in a day can be quantified as 4 women days. If these 4 women work for 5 days, it would add up to 4 women days into 5, which is 20 women days. This is the work required to paint one house. So the work required to paint 10 similar houses would be 10 into 20 women days, which is 200 women days. We need to do this total work in the given time of 20 days. Total work equals 200 women days and total time equals 20 days. So every day, the group should do 200 by 20 or 10 women days of work. And for that, we need to have 10 women coming to do the work. In the question given there, we have a bridge being constructed. 20 men start the work. An accident happens because of which some people get injured and become unavailable for work. We are asked to calculate the time taken to complete the work. In this question, the estimate was that 20 men need to work for 18 days to finish the work. So the first thing that we do is to calculate the total work required to build the bridge. How much is that? 20 men into 18 days. That is 360 man days. The total work to be done to complete the bridge will be 360 man days of effort. When we analyze the situation, we see that there are 2 stages to this construction. One before the accident and the other after that. Let us see how much work is done before the accident. The accident happens after the 10th day. So the amount of work completed before the accident is 20 men into 10 days, which is 200 man days. Thus, out of the total 360 man days of effort required, 200 man days of work is completed before the accident. What remains is 360 minus 200 or 160 man days of work. Because of the injury, all the 20 men are not available for work anymore. We have only 16 men available to complete the remaining part of the work. So we know that remaining work is 160 man days and the workforce available is 16 men. So the number of additional days required would be 160 by 16, which is 10 days more after the accident. The question given involves two kinds of people, men and women. They are involved in making chapatis. As we had mentioned earlier, we should not assume that men and women are equally capable. We can see that they do not work equally. In fact, you can find out that women are doing a better job than men over here. Let us approach this question systematically. We can see that 3 women make 40 chapatis in an hour. So one woman would make 40 by 3 or 13.3 chapatis in an hour. 2 men make 25 chapatis in 1 hour. So one man can make 25 by 2 or 12.5 chapatis in 1 hour. Thus, we see that women are more efficient than men here. In this question, we are trying to find out how many chapatis can the group comprising of 2 women and 3 men make in 6 hours. We shall treat the 2 women to be equally capable and the 3 men to be equally capable. Let us see how many chapatis this new group can make in 1 hour. As 3 women make 40 chapatis in 1 hour, 1 woman would make 40 by 3 chapatis in 1 hour. So 2 women can make 2 into 40 by 3 or 80 by 3 chapatis in an hour. 2 men can make 25 chapatis in 1 hour. So 1 man would make 25 by 2 chapatis in 1 hour. And 3 men would make 3 into 25 by 2 or 75 by 2 chapatis in an hour. So the group comprising of 2 women and 3 men can make 80 by 3 plus 75 by 2 chapatis in an hour. Multiply this with 6 and we will get the number of chapatis 2 women and 3 men make in 6 hours. On calculation, you will get it as 385 chapatis. As we come to the end of this discussion, let me remind you, this was the first part of the time and work discussions. Here, we discussed in detail the concept of man days. In the second part, we have looked at an equally important concept, the concept of unit work, and discussed some scenarios that can be easily tackled with that concept. While approaching time and work situations, never go by formulas and never ever write a single step until you understand the situation clearly. There is no substitute to this understanding. Always use common sense to avoid silly mistakes. For example, you should know that, in general, if more work is to be done by a person, more time would be required. If more people are involved, work gets done faster. If we reduce the number of people, more time would be required to do the same job, and so on. Thank you.